Today we're going to take a look at section 5 in chapter 1. If I get it going here properly, I suppose that would help. So section 5 in chapter 1 is going to be dealing with solving equations, different kinds of equations. We'll start with linear equations, and then we'll progress to quadratic equations. So let's get started. Simple, easy equations, linear equations with no exponents to worry about. I'm going to rush through these first couple pretty quickly. 2x minus 3 equals 7 is your standard equation that you would have solved back in high school. The interesting thing about it, we know that the order of operation, please excuse my dear Aunt Sally, we do multiplications and divisions before we do additions and subtractions. So what's interesting about equations, the first thing you would do here is get rid of the 7 to do it the easy way, okay? And you might say, why are we doing additions and subtractions before multiplications and divisions? And the reason is, really what we're doing here is 2 times the number, subtracting 7, and we want to get 3, okay? That's a process. We start with multiplication, then we subtract 7, we want to get 3. If we want to go backwards and unravel this and get back to the number we started with, x, you're technically going backwards. And it would be much easier to do additions and subtractions first because you're going backwards. So we're going to add 7 to both sides. And we get 2x is 10, divide by 2, and x is 5. And obviously, you don't have to write that plus 7 if you can do it mentally. But standard linear equation. Let's look at the next one. 3x minus 5, 2 times 1 minus x. We need to take the 2 into both parts by distributive property. So 3x minus 5 equals 2 minus 2x. Now, I think it's easiest when you have x's on both sides to get the x's all on one side first. Do you want to subtract 3x from both sides, or do you want to add 2x to both sides? I think it's easier to add the 2x because this is going to turn into a positive 5x, and you don't have to worry about a negative sign. Negative signs are a great source of error. So why don't we add 2x to both sides, and we get 5x minus 5 is 2. Now add 5 to both sides. 5x is 7, divide by 5. X is 7/5 or 1.4. Okay? Nice linear equation, but it had x's on both sides. Okay. Now, how about a more complex equation? Looks like a formula. Q is equal to F over mv squared. And we want to solve that for the letter m. Anytime, and this goes back to day 1 in here, anytime you have a fraction equal to a fraction, okay, a fraction equal to a fraction, you can always cross multiply, and it gets rid of the fractions. I think that's a smart thing to do here. F is equal to, when I multiply this way, and now I multiply this way, qmv squared, right? Okay, so now you want to solve for m, you want to get rid of the q, and you want to get rid of the v squared. So they're connected by multiplication. I'm going to divide by a q and a v squared on both sides. These go away, and we know m is equal to f over qv squared. Okay? How about another one with a lot of variables? A is 1/2 b1 plus b2 times h. I don't know if anybody remembers that formula. It's a formula from back in probably middle school or junior high, in which you were finding areas of trapezoids. A trapezoid looks like this with 2 bases. 2 bases, b1 and b2, the height. Okay, so it's a formula for finding the area of a trapezoid, and we want to solve it for base number 1. Okay, now once again, here's a fraction. All right, I mean, if I was working this problem, the first thing I do is get rid of the fractions. Some of you might take the 1/2 in, then you put fractions 2 places. Why not get rid of the fraction first, multiply, both sides by 2. I get 2a, and the 2's go away. Go away. So now you can take the h into both parts. I have b1h, b2h. And I want to solve it for b1. So I want to get b1 by itself here. I have to get rid of a positive b2h. How do you get rid of a positive? You subtract b2h, b2h, and I'm left with 2a minus b2h equals b1h. So I want to solve for b1, divide by h. There it is. The h's go away. 2a minus b2h all over h. Now, somebody might say, hey, can I divide that h into that h? As long as you do it into both parts, you could do that. 2a over h minus b2. The h's would go away, but you got to take it into both parts. All right? So that's still a linear equation, just a tad bit more complicated than 2x minus 3 equals 7. Okay. Now, so that was a quickie review of linears. Let's go to quadratics. Quadratics, most of the time, are going to have an x squared in. Okay, most of the time. This one will eventually have an x squared in. All right? A lot of different ways you can do quadratics. Okay? For instance, in this problem right here, I can think of 4 different ways you could do this problem. Okay? You could use square roots. You could factor. You could use a quadratic formula. You could complete the square. Okay? So there are all different kinds of ways to do these problems. 5x squared equals 100. There's no x term. There's no x term. 5x squared equals 100. Why not divide by 5? You get 20. Some number squared is 20. How do you get rid of a square? You take a square root. So x could be the positive or the negative square root of 20. Okay? And we can find the square root of 20 is 4.47, so I know it's plus or minus 4.47, rounded off. Okay? That's just finding a square root. All right? Now, this one's got an x term and a squared term. That radically changes everything. You can't find the square root because there's going to be an x term on that side. Can't do the square root. When you have an x squared and an x, it cuts out that whole business of finding square roots. You can't do it. Probably I would try next to factor. All right, so let's bring the 12x over. So I have 4x squared minus 12x equals 0. Now, when we were doing these problems up here, we didn't worry about getting 0 on one side. We were trying to get x by itself. I still want to get x by itself here. But if I'm going to use factoring or the quadratic formula or completing the square, I have got to get everything on one side and get a 0 on this side. Okay? It's different in technique because you have a quadratic equation. How about we try factoring? First rule of factoring. What is common? I can take a 4 out and I can take an x out. Let's do it. Taking the 4 out, there's an x left. Take a 4 out of this. Minus 3 is equal to 0. Okay? Now, here is something you have known ever since back in grade school. Okay? Maybe 3rd or 4th grade. I am multiplying 2 numbers and getting 0. I am multiplying 2 numbers and getting 0. How in the world can you multiply 2 numbers and get 0? There's only one way to do it, and that is if 0 is one of the numbers. So I know that 4x is 0, or x minus 3 is 0, and I get 2 answers. Divide by 4, add 3. I get 2 answers of 0 and 3. You can check it. Put 0 in. 0 squared, 0 times 4 is 0. 0 times 12, 0. 0 equals 0. Put 3 in. 3 squared, 9 times 4, 36. 3 times 12, 36. They check. Okay? That is solving a quadratic equation by factoring. All right? How about the next one? X squared minus x equals 12. Got an x term. You can't use square roots. Get everything on one side. Let's subtract 12 and have 0. And that's why you want to get 0 on one side. Because if you factor it, you're going to have things multiplying together, giving you 0, and you know that one of them has to be 0. So there's a method to my madness here, folks. All right, so we're going to try to factor this. Anything common? No. Difference of 2 squares. Don't be silly. There's 3 terms. Okay? Let's do FOIL in reverse. This is an easy one because there's nothing in front of the x squared. You can simply put an x down in each part, and you now say, I want factors of 12, go by this sign, factors of 12 that subtract to give me 1. And they are 4 and 3. They subtract to give you 12 and they multiply, and they subtract to give you 1 and they multiply to give you 12. Now, I need to take 4 times 3 and get a negative 12. That means one's positive and one's negative. The trick, go to this sign. It goes with bigger, the bigger one. Which is bigger, the inners or the outers? The inners are bigger, so I'll put the minus here, the plus here. Set each part equals 0. And I'm going to get 2 answers of 4 and negative 3. Okay? That is solving by factoring. 2 different examples of solving by factoring. All right. Down here, 2y squared. Well, you know the drill already. Because it's got a y squared and a y, you've got it. You can't use square roots. Let's bring the 3 over. Add the 3 over. And I have that. Okay? Anything common? No. Difference 2 squares, ridiculous. FOIL in reverse. This is a harder one. Put the factors of 3, put the factors of 2. You say the same thing that goes through your mind. I must find, this time, combinations of these that go by the last sign that add up to 7. 3 times 1 is 3, 2 times 1 is 2. 3 and 2, do they add to 7? Nope. 3 times 2 is 6. 1 times 1 is 1. 6 and 1 add up to 7. So you've got it. Now, you put circles around a pair of them that work. So I'm going to put the circles around the 1 and the 1. The ones you circle go on the outers. 1y and 1. The 3 and the 2 go on the inners, but they flip. The 3 comes over here, the 2 here. To get a positive 3 times 1 is positive. They're either both positive or both negative. Makes them positive. Set each part equals 0. Y plus 3 equals 0. 2y plus 1 equals 0. Subtract 3. Subtract 1 and divide by 2. I get a negative a half. Okay? By factoring. One more, it's already set equal to 0. Let's take out what's common right away. How about we take out 5x, and what is left? I see an x squared, and I see a minus 4. Okay? You have 2 things that multiply together to equal 0. So you know one of them is 0. So either 5x equals 0, or x squared minus 4 equals 0. Now, so this one, divide by 5. You get 0. Now look over here. There's no x in that. You could use square roots if you wanted to. Add your 4 back over. Something squared is 4. Doesn't it have to be 2 or negative 2? Okay? But if you're thinking about factoring here, you could also do difference of 2 squares. X plus 2 and x minus 2. When you solve x plus 2 and x minus 2 equals 0, you're going to once again get 2 and negative 2. Okay? All right. How about completing the square? Okay? I've got x squared minus 8x plus 13 is 0. Now, you might say, if I can factor, if I can do square roots, and if I can use a quadratic formula, do I have to do completing the square? Technically, no. You don't have to do completing the square. But I know where we're headed in chapter 2 or 3, can't remember. I know where we're headed. And it's very, very helpful if you know how to complete the square when we're graphing functions. Okay, so I want to talk to you about completing the square today. Now, when I talk about completing the square, all right, let's just think about something here. When you complete a square, like for instance, if I have a square, let's take x plus 3 squared. You write it down twice. X plus 3, x plus 3. X times x is x squared. 3x on the inners, 3x on the outers. They're both the same. You get 6x. 3 times 3 is 9. All right? Inners and outers are always the same. Okay? So you have 6x. 3 is half of 6. And you square 3 to get 9. All right? So you might be able to see where we're headed here. 3 is half of 6. 3 squared is 9. All right, so let's go back up here. Okay, to complete the square, I find it helpful to get rid of the 13. You have x squared minus 8x equals negative 13. I'm going to take it over to that side. All right, now remember this. 3 is half of 6, and 3 squared is 9. Okay? So if you want to complete the square on this guy, right here, you want to put x minus 4, half of 8. Okay? Now, I claim x minus 4 quantity squared would complete the square. It would make a squared term out of that. All right? Let's check our work. And this is the one step that people mess up time and time again, and it irritates the heck out of me. You always have to check your work. When you do x minus 4 times x minus 4, x times x is x squared. Check. Outers, negative 4x. Inners, negative 4x. They're both the same. Is negative 8x. Check. Then negative 4 times negative 4 is a positive 16. Okay? There's a positive 16 down in here. It's not up there. Okay? You don't want this 16 in there. When you square that dang 4, you don't want a 16. You got to get rid of the 16. And if you do it to this side, you have to do it to this side. Okay? So I have x squared minus x minus 4 quantity squared, and I have to do it to both sides like that. I've got to subtract 16 off of both sides. All right? So now, this becomes, right here, this becomes the square term, okay? And that is going to help us to solve the problem. So once you get the square term, like the x, and what did I do with my marker? All right, so once you get over here, we have x minus 4 minus 16 equals, and I think I messed up somehow. Add 16. Give me a second, double check. I think I messed up. Okay, sorry. Senior moment. Right here. I messed up. There, I don't have to do the 16 to both sides. Sorry. This, right here, x minus 4 quantity squared does not equal that. It has a plus 16 inside it. So to get this to be equal to that, I have to get rid of the 16. Now, this stays equal from here to here. I did not have to put it on both sides. So let's get rid of the 16, add 16 over to here, and I get x minus 4 quantity squared is 3. You can now do the square root of this. Square root, so I know that x minus 4 equals the square root of 3, or x minus 4 equals the negative square root of 3. Add 4, x equals 4 plus root 3. Add 4 minus root 3. If you want decimals for that, square root of 3 is 1.732, so 4 minus 1.732 is 2.268. or 4 plus it is 5.732. And there you've got answers. Kind of interesting, you completed the square and you were able to use square roots again. All right. Let's do another completing the square. How about that one? X squared plus 5x minus 7 equals 0. By the way, you can tell this is not going to factor. This is an easy one. There's nothing in front of the x squared. Can you find factors of 7 that subtract to give you 5? No, you can't. Okay? So let's do it by completing the square. Okay? And the last one, I took the 13 over first. Let's let the 7 just hang there and see if we can do it. And maybe I won't have a senior moment this time. All right, so I want to complete the square on this 5. Remember, you cut it in half. So this would be x plus 2.5, or 5 halves. Okay? Now, let's check our work. You always check your work. This squared is this times itself. X times x is x squared. Check. Outers are 2.5x. Inners are 2.5x. 2.5x and 2.5x is 5x. Now, 2.5 times 2.5 is 5 halves times 5 halves is 25/4, which is 6 1/4. After my last senior moment, I'm not sure I trust myself. 5 halves times 5 halves is 25/4, which is 6 1/4. Right. So inside of that, when you square that, there's a 6 1/4. But I don't want a 6 1/4. So I got to get rid of 6 1/4. And there's already a minus 7 is 0. Take both of those to the other side. Is going to be a positive 13 1/4 when you add. So now you can do square roots. X plus 2.5 is equal to the positive square root of 13 1/4 or the negative square root of 13 1/4. Get a decimal for the square root of 13 1/4. It's 3.64. I'm going to subtract 2.5. I get 11, or 1.14 is one answer. And do the square root of 13.25. And I'm going to make it negative. And subtract 2.5. And let me start again. Second square root of 13.25. And because I'm subtracting, and I end up with 3.97. Okay? All right, so there are your two answers. Let me just double check that again. The square root of 13.25 is 3.64. Now you subtract 2.5 and get 1.14. Then you take 3.64 and add 2.5 and make it negative is negative 6.14. I did mess up. Negative 6.14. Do it again. Square root of 13.25. You guys need to find a new teacher. Is 3.64. Make it negative and add negative 2.5. Yep, looks good. Negative 6.14. Okay, that is solving by completing the square. All right, once again, when we get into chapters 3, I think it is so helpful if you know how to complete the square. All right, quadratic formula should be something that you remember from high school. Actually, the quadratic formula, where does it come from, if you ever wondered that? The quadratic formula comes from completing the square on a general equation of a quadratic equation, ax squared plus bx plus c. So if you do the quadratic formula is the opposite of b plus or minus square root b squared minus 4ac all over twice n. Okay? So a is 1, b is 5, c is 2. Right? A is 1, b is 5, c is 2. So we have the opposite of b would be minus 5 plus or minus square root of 25 minus 4 times A times C. All over twice A is 2. Okay? 25 minus 8 is 17. So I want negative 5 plus 17 is 12. Negative 5 plus 17 is 12. Divided by 2 is 6. Negative 5 minus 17 is negative 22. And negative 22 divided by 2 is negative 11. And man, that just does not look right. I'm having so much trouble today. What the heck? Well, of course. Man, I forgot to take, it's 17, but I got to take a square root. Maybe if I go out of the room and come back in, it'll all work out. So I have negative 5 plus the square root of 17 is negative 0.876. I'm going to divide that by 2. I get negative 0.44. Then I have negative 5 minus the square root of 17 equals, and divided by 2, and I get negative 4.56. Okay? Whew, what a struggle. Let's go to the last one. Solved by the quadratic formula. Okay, got to bring the 9 over. Got to have 0 on one side. Okay, so your A is 4, your B is 12, your C is a positive 9. Let's write that. 4x squared plus 12x plus 9 is 0. Do you see how you can take a 3 out? I'm going to divide. Oh, can't take a 3 out of 4. Sorry. Let's do the quadratic formula. Here we go. The opposite of B is negative 12 plus or minus the square root of B squared, which is 144 minus 4 times A times C, all over twice A is 8. Okay? 16 times 9, 144. That whole root goes to 0. So I have negative 12 over 8 is negative 1.5. And I have negative 12, that's minus 0. It's still negative 12. So it's negative 1.5 twice. You can just list negative 1.5 once, and that's your answer for solving by the quadratic formula. Okay, so now that was not friendly. Why did it do that? Okay, so how about fractional equations? Solving fractional equations. Well, right away on this one, 2x minus 1 over x plus 2 is equal to 4 over 5. It's kind of silly to even bother doing this one. Cross multiply. 10x minus 5 equals 4x plus 8. Really, really easy to do. Let's go on to the next one. X over 2 plus 2x over 5 equals 3 over 4. You cannot cross multiply here. You don't have a fraction equal to a fraction. So there's a couple different things you could do. You could simply do this side, get a common denominator, and get a fraction. And then you could cross multiply. There's nothing wrong with that. Okay? I more or less like to get rid of the fractions immediately, right away. What's the common denominator for 2, 5, and 4? I need a 2. I need a 5, that's 10. But for the 4, I need another 2. So it should be 20, should be the common denominator for all three of those. So let's multiply both sides by 20. Okay, 2 into 20 is 10, 10x. 5 into 20 is 4, 8x. 4 into 20 is 5, 15. 18x is 15. Divide by 18, I get 15/18, which you can reduce to 5/6 by getting rid of the fractions immediately. 1 to go. How about x to the 4th minus 5x squared plus 4 is 0. Can't do it in our head. It's not linear. It kind of looks like 4 in reverse, doesn't it? Right? And you might say, oh, it should be an easy one. There's nothing in front of the x to the 4th. Okay, let's try it. So doesn't this have to be the case? X squared and x squared to get x to the 4th because you want an x squared in the middle. Now, it's an easy one. So what are factors of 4 that add up to 5? Not 2 and 2, 1 and 4. To get a positive 4, they're either both negative or both positive. But because of that, we better make them both negative. 2 things multiply together equaling 0. One of these guys has to be 0. But wait a second. I can do square roots on both of them. Add the 1 over. Add the 1 over. What squared is 1? It's either the positive or the negative square root of 1. Add the 4 over, positive or negative square root of 2. Okay? This is kind of a really cool equation. Okay? Really cool equation. Just, sorry, can't help myself here. We have that it's when x is 1 or negative 1, the y value is 0. So here's 1 and negative 1. When x is 2 or negative 2, the y value is 0. Okay? Other than that, when x gets bigger, this thing just explodes upward. So this thing comes down. Oh, isn't that a neat function? Really neat function. Okay. Sorry for my missteps today. I was having a couple senior moments. There is your homework, one extra problem, and a variety of book problems. I went through the book and tried to pick out the best problems, a few from each section in section 5, to give you some kind of an idea as to what's going on with solving equations.